I always tell the story in class about how Napoleon tried to impress the King of Italy by using aluminum cutlery as a way of being impressive because aluminum was such a rare metal back in 1800s. Now, of course, we wrap our sandwiches with it. So how did aluminum become so cheap? Well, the answer is we can manufacture it now. We can pump electricity into a molten vat of some sort of aluminum salt and pump the electrons back onto the aluminum ion and remake the aluminum metal. Now, this is a non-spontaneous process, right? Metals lose electrons in chemical reactions. So if I want to put the electrons back on, I've got to pump them back on using electricity. You know, so we're going to look at two examples here. First example is where we get sodium, right? Sodium metal for class. We love throwing in water and watching it explode. Well, sodium metal is so reactive you can't find it anywhere. As soon as it reacts with anything, gets in contact with any kind of non-metal, it reacts. So we use something like sodium chloride, right? Table salt. You melt it so that it's molten so that it'll conduct electricity, and you pump electricity through it. At the cathode, you're pumping the electrons back onto the sodium ion, right? This is going to be the oxidizing agent here, sodium ion, right? Such a poor taker, but we can pump the electrons back on it to reform the sodium metal. Over at the anode, you actively have to take those electrons off of the chloride to reform chlorine gas. So, chlorine doesn't want to give up that electron, you have to rip it off. So we use electricity to pump the electrons off of the chloride ion and put the electrons back on the sodium metal. Same with water, right? We've done this demo in class. We have to pump electricity through a water with some sort of electrolyte in it in order to pump the electrons back onto H plus ions and suck the electrons off of oxide. So over at the cathode, H plus ions are having electrons put back on them to make hydrogen gas. And over at the anode, we're oxidizing the oxygen in water, right, which has got a -2 oxidation state, to turn it back into oxygen, 0 oxidation state. All right. So over at the anode, we are removing 4 electrons from 2 waters, and we've got to pump 4 moles of electrons onto 4 moles of H plus in order to form 2 moles of hydrogen gas. So in this process, 4 moles of electrons are being transferred, right? 4 moles of electrons are going in, 4 moles of electrons are going out. All right, so in terms of answering a question, right? The question could be, how much electricity is required to make a certain amount of hydrogen gas? Or the other question would be, how much chlorine gas would be produced if I pumped a certain amount of electricity through it? So those are the two types of questions you run into. Faraday observed that the mass of the product formed or the reactant consumed at the electrodes is proportional to the amount of electricity transferred. So what we need to know is how much electricity are we putting into the system. And when we do that, we're looking at amperes. Amperes is a measure of current. So when we talk about volts being the amount of push the electron has going through the wire, right, the amount of energy, amperes is the amount of electricity going through the wire. And it's measured in Coulomb seconds. So how much charge is passing a given point per second gives me a measurement of current. All right, so steps involved in terms of calculating amount of substance oxidized or reduced. So this is one of the questions. So what I'd need to know is how much time went by. They'd have to give me how much time went by. And then I could use the definition of coulombs. All right, I'd have to know what the current was. They'd have to tell me how much electricity was put in, what the amperes were. So now I can use seconds and coulombs per second to convert to coulombs. We use the definition of Faraday as a conversion factor to go from coulombs to moles of electrons. I have to know how many moles of electrons it takes to oxidize or reduce the substance I'm interested in. And then I can use the molar mass to get to grams. So this is a typical problem. A current of 0.452 amperes is passed through an electrolytic cell of molten calcium chloride for 1.5 hours. write the electrode reactions and calculate the amount of quantities formed at the electrodes. All right, so when we look at calcium chloride, you're not going to be pumping electrons onto the chloride, right? You're going to be sucking the electrons off of the chloride. So at the cathode, you're going to have the calcium 2 plus ion having electrons put back on it. And over at the anode, you're going to be taking the electrons off of chloride to make chlorine gas. So it takes 2 moles of electrons to reduce calcium 2 plus to make calcium. Therefore, I'd have to use 2 moles of chloride to make 1 mole of chlorine gas. Okay, so there's my reaction. So what I need to do is have my time in seconds, right? Because amperes is coulombs per second. So if I multiply seconds by coulombs per second, I get coulombs. I can use the definition of Faraday, 96,485 coulombs per mole of electrons as a way to convert to moles of electrons, right? Put coulombs in the denominator, moles of electrons in the numerator. As we just saw, it takes 2 moles of electrons to reduce calcium 2 plus, and the molar mass of calcium is 40 grams per mole. So I can calculate how many grams of calcium I'm producing over at the cathode. Over at the anode, again, I've got to get my time into seconds, use the current, how many amperes to get to coulombs, use Faraday's definition to get to moles of electrons, and again, 2 moles of electrons to make a mole of chlorine gas, which weighs 70 grams per mole to get grams of chlorine produced. So this is an example of one of the types of reactions. We can go the other way, right? I could say, hey, I could start off with, I want so many grams of chlorine gas produced, and then I'd go backwards, right? Use the molar mass to go from grams to moles, from moles of substance to moles of electrons, from Faraday to moles of electron to coulombs, from coulombs to seconds, and I could figure out how much time. So backwards or forwards in this problem, these are the 2 types of problems you're going to run into.